Hey, so welcome to section 5.2, which is on fractions. So we're going to talk about the three meanings of fractions because there's different ways that you can interpret the same fraction. So take a fraction like 3/4, for example. There's different ways that you can interpret that meaning. So the first way that you can interpret a fraction is we call it part whole. So what that means is that if you have a fraction like 3/4, the top represents a part and the bottom represents a whole. And then more specifically, like when I say whole, that's talking about how many pieces are in the whole. So for example, you could have a pizza that's divided into 4 pieces and you're selecting 3 or eating 3 out of 4 pieces. So you'd say I ate 3/4 of the pizza. So it's talking about one whole that has 4 pieces, and then you're identifying 3 of those 4 parts. So an example of a part whole picture, or there's several here. There's 8 examples below that represents this part whole idea of a fraction. So this would be a great time to pause the video and try these on your own. So let's write a fraction for all of these. So we're going to start with this circle here. So it looks like there's 8 pieces all together. So the bottom, the denominator is going to be 8, and 3 are shaded. So we say 3/8 are shaded there. For 2, we're going to write the fraction of x's. So there are 16 boxes in the picture. So 16 is going to be the denominator, and there are 1, 2, 3, 4, 5, 6, 7 x's. So we write a 7. For number 3, it looks like there's 6 pieces all together. 1 is shaded, so the purple represents 1/6 of the whole. And then for 4, looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces total, 9 squares total, and then 1, 2, 3, 4, 5 M's. So 5/9 is the picture that's shaded with M's. This one, oh, you know what? I forgot to fix this. I'm going to draw this so you can see the whole thing, but what it's meant to look like is this. And so we'll write 2 out of 3 there. 2 out of 3 pieces total, 2 of them are shaded. And then number 6, what fraction are circles? So out of the whole picture, there are 1, 2, 3, 4, 5, 6, 7, 8 shapes, and there are 2 circles. Now, if you know how to reduce, you could also reduce this. So you could say 2/8 is the same thing as 1/4. And we get that by dividing these both by the common factor of 2. But 2/8 is the same thing as 1/4, so we can leave it as 2/8 also. So with fractions, it's important just pay attention to the directions if you're working on your homework and whether or not the directions ask you to reduce your answer or not. For 7, what fraction are squares? So we've got 8 shapes still, and then there's 1, 2, 3, 4, 5 squares, so 5/8, and then there are 8 pieces total. There is 1 triangle, so 1/8 are triangle. And if you notice, look at all the fractions from 6, 7, and 8. We've got 2/8, 5/8, 1/8, and if you add 2 plus 5 plus 1, you end up getting 8 out of 8, which is equal to 1, which is the entire picture. So we identified all of the different types of shapes there. So the other way that you can use fractions to represent a quantity would be what we call the quotient definition of a fraction. So 3/4 could mean 3 divided by 4. Okay, and so that means 3 of something. So 3 is kind of like this represents 3 wholes, and then you're dividing them into 4 groups basically. So imagine for a minute that you have 3 cookies. This happens in my family all the time. We've got 3 cookies, there's 4 kids, and each of them wants some cookies. How do you divide them up? Well, we could divide these by 4, which gives us 12 pieces altogether. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 fourths there. So every person would get 3/4 of a cookie. So I'll use a different color just to shade this in. So this could be person 1. This could be person 2. This could be person 3. And this could be person 4. So 3/4 of a cookie, each person. So an example, some examples that have that are similar and use this quotient concept would be below. So example 2A, 2 gallons of cider are poured into 7 containers in equal amounts. How much cider is there in each container? So it'd be a great time to pause the video and try this. So I want you to imagine, so we've got 2 gallons of cider. So imagine this is 1 gallon of cider, 2 gallons of cider, and then we have 7 different containers. So 1, 2, 3, 4, 5, 6, 7. How could we divide these up evenly so that way each of these 7 containers get an equal amount? And one thought would be, if you've got 7 containers, divide them into 7 sections. So if I take this container and I divide it into 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and I'll do the same thing here. Okay, so each of them have 7 sections. Well, if I could give one of these 7 sections to this cup, and I could give one of these to this first container. And then I could give one of these 7ths to this second container, and I could give the next 7th in each container to this third container. So every person or every container, imagine these are glasses, and you know what, let me fix this green one here so it looks like it's going to the second one. Every single one of these containers would get 2/7 of a gallon of cider. And if we write that, we could actually write it out like that. So we could say 2/7, 2/7, 2/7, 2/7, 2/7, 2/7, 2/7. So if every container got 2/7, let's add those all up. So I know we haven't talked about adding fractions yet, but if you have the same denominator, 7, we keep the denominator and we add the numerators. So 2, 4, 6, 8, 10, 12, 14. Well, what's 14 divided by 7? You end up getting 2 gallons. So if you add 2/7 up 7 times, then you end up getting 2 gallons, which is exactly what we have to start with. So dividing 2 gallons up into 7 containers, each person would get 2/7 of a gallon of cider. So the next one is very similar. So 4 acres of land. So instead of the 2 gallons, now we have, imagine 4 acres here. Just draw a picture. Each one of these squares is an acre. They're divided equally into 15 parts. How much land is in each part? So if we divide it up into 15 parts, then each one of these is going to have to be divided into 15. So imagine dividing these acres into 15 pieces. It's hard to do here because they're so small, but if each of them have 15 pieces, then you could take a 15th from each one and give it to a part. So the answer would be 4/15. And you could also think of this as 4 being divided into 15 parts. Okay. So these are the same thing. Okay. The last meaning that we're going to talk about is a ratio. So the fraction 3/4, okay, so we're still sticking with the same fraction here. The 3/4 can also mean a ratio, like there are 3 girls to every 4 boys. And you can also write a ratio using the colon here. So a picture that you could use to represent this might be 3 girls like this for every 4 boys. So that would be 7 kids total. You could also continue. You could think of like a classroom, for example. Maybe there are more than 7 kids. So this is an example of 14 children, but there's still a ratio of 3 girls for every 4 boys, because in this instance we have 6 girls. Whoops. Come on. There we go. We've got 6 girls and we have 8 boys. which still reduces to 3/4. So when you're dealing with a ratio, it doesn't necessarily mean that there are always exactly 3 girls and 3 boys. There could be quite, there could be quite a lot of people, quite a lot of kids, but if you reduce it, there should always be a ratio of 3 girls to every 4 boys. Okay, so the last example, example 3, it takes 4 red rods to equal the length of 1 brown rod. So I'll just draw a picture for that. So if we have 1 brown rod, and then we've got 4 red. So red, 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 red. So there are 4 reds for 1 brown. And then it says there are 5 whites to equal 1 yellow. So we'll call this yellow. And then we'll say white, 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 and then white. So part A says if the brown rod is the unit, meaning brown is equal to 1, what is the length of a red rod? So if this, let me just use a different color. If this right here, this length is equal to 1, then one of these reds would be 1/4 of the length of brown, because there are 4 reds in that 1 unit. And then part B, if the yellow rod is the unit, meaning the yellow, this length is equal to 1, what is the length of 3 white rods? Well, let's first look at what 1 white would be. So if there are 5 whites altogether, then each one of these would be 1/5. And if there are 3 whites, then that would be 3/5, because there are 3 whites total. So that concludes the 3 ways that you can represent a fraction or understand what a fraction means. So let's talk about what it means for 2 fractions to be equivalent. So equivalent fractions are fractions that share the same value, but that have been written in a different way. So for example, the fraction 2/4 is equivalent to 1/2 because they represent the same amount or value, but you can draw a picture and show them a little bit differently. So for example, 2/4 means we have some sort of quantity. We'll call it a circle in this example. We'll say the circle is divided into 4 pieces, and then we're gonna shade 2 of them. So 2/4 represents 2 parts out of 4 would be our whole. So 4 pieces total. And then 1/2 represents 1 part out of 2 pieces. So I'm going to divide this into 2 and then shade 1. And you can see with these pictures, they both represent the same amount. We just got there a little bit differently. So if we would like to convert one fraction into an equivalent fraction, you can do a couple different things. So for example, 2/4 and 1/2. How do we, what could we do to 2/4 to make it 1/2? One option would be to divide both of the numbers, the numerator and denominator, by the same number. So we look for a common factor, preferably the biggest one, but just any common factor will do. We can start there. So 2 and 4 are both divisible by 2. So if I divide them both by 2, then I end up getting 1/2. So that's one way. You could start with 1/2 and go the other way around and say, well, what could I do to 1 to get 2? Well, I could multiply it by 2. And then whatever you do to the 1, the numerator, you've got to do to the denominator. So 2 times 2 gives us 4. So I could either divide them by the same number or multiply them by the same number. So example 4 asks you to use one of those strategies to complete the equivalent fraction. So this would be a great time. Pause the video and try this on your own. So for 5/8, I really want to focus on this 8 here because I know I can compare that to the 32. So I could ask myself 8 times what gives me 32, or I could say 32 divided by what gives me 8. I'm going to go this way because multiplication is a little bit simpler. So for me anyway, so 8 times 4 is 32. So then I just have to do 5 times 4 is 20. So 20 over 32 is the same thing as 5/8. So 21 divided by 3 is 7. 3 divided by 3 is 1, so 1/7. And I could have, I know I just said, let's stick with the multiplication. You could have done this using multiplication, and I'll show you that also. So 7, if you just went the other way, 7 times 3 is 21, then you could ask yourself, what times 3 is equal to 3? And your answer would be 1. I think in that case, it's probably easier to do the first way that I showed you, but either one works. So with this one, 39 divided by 3 is 13. So 9 divided by 3 is 3. So 3 over 13 is going to be our answer there. 8 times 7 is 56. 3 times 7 is 21, so 21 over 56. And then we can say 4 times 11 is 44, so 7 times 11 is 77, needs to go on the bottom. And then with this one, we can go 25 divided by 5, and notice I'm choosing the direction that I'm going in has to do with where the question mark is at. So I find it easier to start with a number and then go towards the question mark, so that way I'm not guessing the number, I'm actually performing an operation to find the number, but you can go either way. So that's what makes me start with the 25 and go towards the 5 rather than the other way around. So 25 divided by 5 gives you 5, so 45 divided by 5 is going to give you 9. So the answer for this one is 5 over 9. Okay, so we just found equivalent fractions. Now we're going to talk about how to simplify fractions. And the reason we're doing all this, we're basically gearing up for the next section, which is adding and subtracting and multiplying and dividing. So when we do operations with fractions, we're going to need to know how to do all of these, calculations. So fractions can be simplified if the numerator and denominator have a common factor, okay? So that means there's a number that they can both be divided by exactly, meaning giving you a whole number answer. So if you want to write the fraction in the simplest form, you need to find the highest common factor. So what does that mean? Let's look at this example. So 24 divided by 48. 24 has a lot of factors. 48 has a lot of factors. What is the biggest factor between the two of them? So the greatest common factor of 24 and 48, you can do your process that we learned about in the last section. You can do a factor tree and list out all the factors. You could just do the rainbow factors and find the highest one. The highest common factor for both of these is 24. So what we can do is we can divide both of these numbers by 24. And the reason that works is, think about it, 24 divided by 24 is just 1. So it's kind of like we're just dividing this by 1 or multiplying it by 1. So 24 divided by 24 is 1. 48 divided by 24 is 2. So the simplest form for this fraction would be 1/2. Now, let me show you though, if we started with 24 over 48 and you divided it by a different number, you could still end up with the same answer. So let's say you look at these and you think, they're both divisible by 2, which is true. Then you get 12 over 24. And then you might look at these and say, oh, well, those are divisible by 2 as well. So then I get 6 over 12. Oh, those are divisible by 2. You get 3 over 6. Oh, those are both divisible by 3. And you end up getting 1/2. So that would be the longest way to get there. And then this would be the shortest. And then there's definitely some other blend of methods that, are in the middle. So try example 5. So it says determine which fractions are in the lowest terms. If it's not, write the fraction in simplest form. So 3/8. This is in lowest terms. 3 and 8 don't have any common factor other than 1. 4/15. This is in lowest terms. Negative 8 over 24 is not. Both of these numbers are divisible by 8. So I get negative 1 on the top and 3 on the bottom would be the simplest terms for that. 18 over 30. These are both divisible by 2. They're both divisible by 3. They're both divisible by 6. So to make things faster, I'm just going to go ahead and divide both by 6. So 18 divided by 6 is 3. 30 divided by 6 is 5. If you wanted to start with 2 and then keep going, that's totally fine. You could have ended up with 3/5 going that route too. 10 over 21, that's in lowest terms. And then 10 over negative 15, that's also in lowest terms. So now that we've talked about lowest terms, we're going to jump into getting a common denominator. So this is something that we're going to need to do for the next chapter when we add in and subtract fractions. So it says, example 6, replace the fractions in each pair by equal fractions having the least common denominator. So for example, 4 and 5, that's not a common denominator. Those numbers are different. So how could we make them the same? So think about numbers 4 and 5 and think about their least common multiple. So for 4, the multiples of 4 are 4, 12, 16, 20, 24, 28, and then so on. And then 5, we have 5, 10, 15, 20, 25, and so on. They both have 20 in common. So that's the least common multiple for 4 and 5. So what you're going to do is you're going to come up here and say, well, what do I do to 5 to get 20? I multiply that by 4. And if I do it to the bottom, I have to do it to the top. How do you get 20 on the bottom over here? I multiply 4 by 5. And if you do it to the denominator, you have to do it to the numerator. So 4 times 5 is 20. 5 times 3 is 15. So 15 20ths is the same thing as 3/4. And then 5 times 4 is 20. 2 times 4 is 8. So 8 20th is the same thing as 2/5. So 12 and 8, what is the least common multiple for 12 and 8? Well, they both go into 24. So I'm going to multiply this by 3 and 3 to get 24. And I'll multiply this by 2 and 2. So 8 times 3 is 24. Negative 3 times 3 is negative 9. 12 times 2 is 24. 7 times 2 is 14. And one nice way or easy way to check these, let me just pull up my calculator real quick. If you're ever not sure, what you could do is you could divide them. So you could take 7 divided by 12 and get the decimal equivalent to that. And then so you get 0.583 repeating. And then let's do 14 divided by 24. Oh, did I do the wrong one? Let me see. 7 over 12 you know what, let me, for some reason, my calculator is freezing up. Okay, so you know what, I'm going to forget that right now. I'll start it later, but what you could do is just do 7 divided by 12 and get the decimal equivalent, and 14 divided by 24, get the decimal equivalent, and you should get the same answer. And that's a really fast way of checking. Okay, so let's move on. Let's do 1/6 and 5/18. So this one, 18 is actually a common multiple. So you can leave this one alone and just multiply this one by 3 and 3. So 3 and 1 is 3. 3 times 6 is 18. And then we can leave this the same. So that happens often when one of the fractions can just stay the same. And then 4 and 7, the least common multiple for those numbers is 28. Now keep in mind, you can always multiply the denominators. That will always give you a multiple. It might not always give you the least common multiple though. So for like this one, for example, if you multiplied 12 times 8, you get 96. Now could we use 96? Yes. Is it the least common multiple? No. The downside to using 96 would be that if you were adding or subtracting fractions, you might get some bigger numbers in the numerator. But you know, in the end, you could still get the same answer. So for this one, 28 is a good is the least common multiple. So I'm going to multiply 7 by 4 and 3 by 4, and then I'm going to multiply this fraction by 7. So 7 times 4 is 28. 3 times 4 is 12. Negative 4 times 7 is negative 28. and then 7 times 1 is 7. And actually I missed that. So if we want a common denominator, we also need to make sure the signs are the same. So negative 28 and 28 are not common. They're not the same. So I actually have to multiply this by negative 4 and negative 4. So this is negative 12 and negative 28 there. Okay, so speaking of negative fractions, this leads us really well into this next section. So this box right here, rules for signs of fractions, basically just tells you how you should treat a negative sign in a fraction. So if you have a negative sign in the denominator of a fraction, it's best to either write it above with the numerator or out front. So for example, negative 2/4, that's the same thing as 2 over negative 4. It's the same thing as negative 2/4. I would say that these last two methods are preferred over the first, but the first is not wrong. So either all of these represent the exact same value. And then the test for equality box, that talks about a strategy that you can use if you want to test if two fractions are equal. So if you want to test if two fractions are equal, you can do what's called cross multiplying. So A times D and see if that's the same as B times C and see if those are equal. So for example, if you want to test 1/2, is that equal to 2/4, which we found that it was in a previous problem, but let's check. So we can cross multiply 1 times 4, which is 4, and then 2 times 2, which is 4, and yes, those numbers are equal, so it shows that those fractions are equivalent. So with example 7, it says determine whether the fractions are less than, greater than, or equal. Now you could use the test for equality for these to see if they're equal. The bummer about that, though, is if they're not equal, then the test for equality doesn't help you decide if you should use the less than or greater than sign. So my preferred method, if you're trying to order fractions or determine if they're equal, is just to get a common denominator. So this works no matter what the problem is. You can also draw a picture, but that has some downsides. I'll show you real quick. Like for the second one, I wouldn't draw a picture for this one because the denominator is way too big. But like for 3/4, you could draw any shape you wanted to. I like rectangles for fractions, but draw a shape and try to be as exact as possible. Divide it into 4 pieces, and then I'm going to shade 3. And then you need to draw the exact same size shape. This is where it gets tricky if you're not measuring. You got to try your best. And then you divide it into 9 equal pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Okay, and then you shade 7. So 1, 2, 3, 4, 5, 6, 7. Now, the tricky thing about this is now you have to line these up and say, okay, which one is greater? Now, it looks like this bottom one is just a hair bigger than that, so my inclination is to say this, but it would still be better to get a common denominator. So let me show you how to do that. So let's get a common denominator like we did on the last page. So I will find a common multiple. So I'm going to multiply this by 4, and I'm going to multiply this side by 9. So 9 times 3 is 27, over 9 times 4 is 36. 9 times 4, 36. 7 times 4 is 28. If the denominator is the exact same, this is like saying I have 2 pizzas, they're both divided into 36 pieces that are the same size. Which is bigger, 28 pieces or 27? You would say, well, 28 pieces if they're all the same size, because 28 is bigger than 27. So we were right with our picture, but this makes us feel a little bit better about our decision. So let's go through and do the other one. So let's find a common denominator. So if we multiply 35 by 3, we end up getting 105 on the bottom, which is perfect, because then that's the same. And then 14 times 3 is 42, and then we find that those are actually equal. You could have used the cross multiplication process at this point and found out that if we multiply the diagonals, they're equal. That would have also worked. And then with this one, I'm going to get common denominators too. So I'm going to multiply that by 7. And then I get negative 15 on the top, 35 on the bottom. And then now you have to ask yourself which number is bigger, negative 14 or negative 15. Negative 14, it's closer to 0. Negative 15 is more negative. And then this last one, we've got a negative and a positive, so I know that the positive is going to be greater than the negative without even getting a common denominator. So let's talk a little bit about mixed numbers and improper fractions. So an improper fraction is a fraction where the numerator is bigger than the denominator. So for example, 8/5 is an improper fraction. You can take improper fractions and make them into what's called a mixed number. 8/5 is the same thing as 8 divided by 5. So if you take 8 and you divide by 5, 5 goes into 8 once. 1 times 5 is 5. The remainder is 3. And how you can write that is you can write it as the answer 1 and 3/5. So the top, the numerator, is the remainder, the 5 is the divisor, and the 1 is the quotient. So 8/5 is the same thing as 1 and 3/5. So visually, this example 1 here, if we could write a mixed number and say this is 1, 2, 3, 4 and a half. This one that's 1, 2, and then this looks like a third since it's divided into 3 pieces. So 2 and a third for that one. And then for part 3, write the missing mixed number above each improper fraction. So we've got, these are negative numbers on the side, so negative 10/5 is the same thing as negative 2. Negative 9/5 is the same thing as what? So what you can do is you can say 5 goes into 9 one time with 4 left over, and 5 you keep the original denominator. If you can't do that in your head, it's totally fine. You can just do 9 divided by 5. 5 goes into 9 once with a remainder of 4. And so you always write the answer, the top number is going to be your first number in the fraction. The remainder is going to go in the numerator, and then the divisor, which is that 5, is going to be in your denominator. So negative 1 and 4/5. And then down here, 1 and 3/5, if we want to go the other way, backwards, 1 and 3/5, we can do 5 times 1 plus 3. So 5 times 1 is 5, plus 3 is 8. And then we keep the original denominator. The other thing that we can do is we can just go and use this part of the number line. So negative 10, negative 9, the next number would be negative 8/5. And then we could count 7/5, negative 6/5, negative 5/5. Okay, and then we come to 0, and then we can come to this side. So if these are all fifths, 1/5, 2/5, 3/5, 4/5, 5/5, 1 and 1/5. 1 and 2/5, 1 and 3/5, 1 and 4/5, and then 2. And then down here, we're looking at the improper fraction. So if we have 5/5, then we could write this as 6/5. I know it doesn't ask for it, but we can write it in. Then this would be 7/5, 8/5, 9/5, 10/5. So the bottom are all improper, and the top are all mixed numbers. Okay. And then last but not least, just like the other sections that we've been doing in chapter 4, we've got some mental calculations and approximations. So it says draw a picture to mentally determine which fraction is bigger, 1/12 and 1/5. So just like that last example, when we were getting common denominators, you could draw a rectangle for each. And again, it's really important that you just try to make your rectangles the same size, otherwise you really cannot compare. And then I'm going to divide 1 into fifths. So 1, 2, 3, 4, 1, 2, 3, 4, 5, not too bad. And then this one into 12. So I'm going to divide it in half, and then in quarters, and then I'll divide these all in thirds. And that should give me 12. Okay, and then we've got 1/12 and 1/5. So it's clear that 1/5 is bigger. The other thing that you can do without even drawing a picture is if you think about 1/12 and 1/5, if the same size shape is divided into 5 pieces, these pieces are going to be larger than if you were to divide it by 12, or think of it as a pizza. If you were to divide a pizza into 5 pieces, those pieces are going to be a larger size than if you divide them into 12 pieces. So, and this is why it's always funny to me when if you're ordering pizza, they advertise the number of slices. Really, you want to know how big is the pizza, because they could divide it and put lots of slices in the pizza and have them be really small. That doesn't mean as much to me as the actual size that you're starting out as. So if the pieces are bigger with fists and you have one of them, then that's going to be larger than if you have one piece of these smaller size pieces. So I know it seems odd because the bigger number is the smaller piece, but that's the way it works because you're dividing it into more pieces. And then last but not least, so it says replace each fraction or mixed number by a close approximation that is in simpler form. So think of what you could change this to be. Like, what would be an easier number to divide by to 30 other than 17? And the first thing that comes to my mind would be 15, because 15 and 30, 15 is half of 30. So if this was 15 over 30, then it would be approximately 4.5. So that's pretty close. 12 and 5, 26. 26 is really close to 25. 25. So I could say this is approximately 12 and 5 25ths, which is the same thing as 12 and 1/5 if I were to reduce this by dividing both by 5. So that's the end of the section. Stay tuned for the next section, which will be on adding, subtracting, multiplying, and dividing, and we'll use all of the strategies we learned about today to do that.